Hello and welcome. This tutorial is to help us describe how many zeros of various kinds there are given a very general polynomial. To illustrate this, I have on the board here a polynomial of degree 9. I know it's degree 9 because the leading coefficient right here is a 9. So what we're going to do is we're going to go through the various questions that are associated with these types of polynomials. To get us started, we have been told of some known zeros. So these are the known zeros. Now you need to recognize that anytime you have a complex zero of the form a plus bi, there are also other zeros that are its conjugate. So an example of another zero would be simply 5 minus I, or 1 minus 5i, or 4 plus 4i. These are simply the conjugates. So we're going to put here, look for conjugates. So the next question is, how many real zeros could there possibly be? Well, first of all, the total number of zeros for this one is going to be 9, because it has degree 9. So there's 9 total zeros. The number of complex zeros on the screen here is 6. So there are 6 complex zeros shown. So through simple arithmetic, if there's 9 total and 6 of them could possibly are complex, that means that there are 3 real zeros potentially. So how is it possible to even ask at most how many imaginary zeros? We have 6. Well, in the question it just says these are known. There are 6 known, but there could be more. And we're going to say that the complex zeros come in pairs. So therefore there could be 2, 4, 6, 8, but not 10. So ask yourself, why not 10? Well, there are a total of 9. Zeros, so therefore the most complex or most imaginary is the highest even power, which is 8. So now I have a new problem upon the screen here. This time is of degree 10. And our known zeros are going to be 5, 5 minus 4i, 5 plus 4i, and 2 minus 3i. So again, the first question is, what is another zero? You're looking for conjugates. Well, 5 minus 4i and 5 plus 4i are already conjugate pairs. So the only possible one here is going to be 2 plus 3i. That's the only one. At most, how many real zeros? So therefore we're looking at is there are currently 4 known complex. So therefore if there's a total of 10, 6, I should say at most 6, are real. This is key, again, because we know 4 complex zeros exist. There may be more. And since it's a general polynomial, we don't know what the possibilities are exactly. At most, how many imaginary zeros? Well, here we need to take into account, unlike the last one, that we already know there is one real zero. Which is the 5. So what difference does that make? Well, if the 5 up here is a 0 and it's a degree of 10, that reduces as 1 out of 10, but you can't have 9 complex. So let me write that down. Can't have 9 complex. So the next highest even power is 8. There are 8 at most imaginary zeros. Again, remember that for the imaginary, the complex zeros, they always come in pairs. Always. So this number here has to be 2, 4, 6, 8, 10, etc.